Good morning to you all. Myself Vinayaga Murthy. Today we'll see the webinar on T-girder bridge, which is modeling analysis including the live load as per the BS standard. This is a software screen. Now we will do before doing the modeling. This is the top view. I'm just save the model. And for the grillage model, first I'm making the properties. Go to properties, material properties, add. I'm defining the property for the concrete as per the BS standard, C40 grade. I'm changing the name as concrete. Apply. And another property for steel. $50D, this is for the steel property. This property I'm defining for the Prestress cable. Next is section property. Add. This is section database. Here we are defining the section as a box girder section. I'm selecting PSC N cell type. I'm giving the name as deck. Number of cell is 2. And H1 from the reference picture, I'm giving the dimensions. H1 is 2 meter. H2 0.3. Okay, I'm giving the name as a support section because I would like to show the tapering section and the box girder also. This is support section. H is 2 meter. H2 I will make it 0.5 and H3 is 0.3 and H4 0.5, H5 0.5 and B1 is 12 meter, B2 2 meter and B3 0.5, B4 0.3, B5 0.3 and B6 is 0.5. So this is the cross section which we are defining for the support section. And the wave thickness for shear and torsional calculation, I'm selecting automatic function. And here the offset is center top offset so that we can maintain the top surface should be uniform. This is centroid display in the geometry. This is my support section and add. Support section is added. Next is I'm giving as a mid section. I'm giving the name as mid. And here I'm changing dimensions. H2 is 0.3. H3 is 0.2 and H4 is 0.3, H5 0.3 and B3 is 0.3 and B4 0.3 and B6 also 0.3. So this is the less wave thickness cross section for the mid section. Add. Second cross section is added and next is a taper section. I'm selecting the same PSC type. PSC N cell type. I'm giving the name as support to midsection. Import a support section property. Import and J10, that's the right end of this cross section. This is from midsection. So the tapering will be from this section to this section, and the tapering wise, it's a linear tapering in y direction and z direction. So y and z is a linear type. Again, your offset is center top offset. Apply. So the third section is added in the cross section list, and next cross section is mid to support. So ith end is mid section and jth end is support section. Same linear tapering, center top offset, and click OK. So totally we have defined 4 cross sections. Okay. Now you can see the work. This is the work we have done. We have defined 2 material property and 4 cross section properties. And then we have to define the time dependent material property for creep and shrinkage and shrinkage strength calculations. This is mainly for the Prestress loss calculation as well as the time dependent variable effect on the structure. So I'm changing the unit to Newton millimeter. Creep and shrinkage. Add. So I'm following the ACA standard for calculation of creep and shrinkage. This is C and S. Compressive strength is 40 Newton per mm square. Relative humidity is 70%. Volume surface ratio is 1000 millimeter, and age of concrete at the beginning of shrinkage is 3 days. And concrete compressive strength factor A and B, it's as per the standard, A is 4 and B is 0.85. The ACI code and the slump value we have to give, or we can make it user defined. This is as per the codal value, as per the user defined. I can make the material factor, I make it the factor is 1.3, and material factor ultimate shrinkage strain and giving 4 and 5. Show result, this is our creep coefficient and shrinkage strain. A similar way, the compressive strength factors, I'm giving the name compressive strength. This is age of concrete at 28 days. It's 14 Newton per mm square, and the factor is 1.2 and B is 0.85. Show graph. This is the compressive strength variation. Now we are seeing the 100% strength, that's M 14 Newton per mm square, which we are reaching at the 28 days. Based on the factored values. Now we have defined the creep and shrinkage and compressive strength. Now we have to connect these 2 parameters along with the material properties. For that I have to make a material link. So go to material link. This is a creep and shrinkage, compressive strength, this is a concrete property, added, add. So this creep and shrinkage and compressive strength factor belongs to the material property. So this we have linked only with the material property. Fine. So now your material and cross section is defined. Now we have to make the geometry. Next is the node and element. Create the node. First node at the origin point. Click OK. Now you are seeing the node number is created. The first node number is created at the origin point. We have created only 1 node here. You can see the node number, it is displaying here. Now I'm using the extrude command where I can directly generate the cross section with defined material and cross sections. Okay. Extrude command, this is the node to line element. We have 3 types of extrusion. Node to line, line to plate, plate to solids. Now I have created only node, so I'm using this function, that is a node to line element function. Now this is my concrete property. This is first cross section is support section. What is the length of my segment? I'm making an unequal distance is x direction. This is my 2 meter. First cross section is 2 meter. I'm selecting the node and apply. Sorry, the unit is in millimeter. I'm changing the unit to meter because I have to make a 2 meters. Apply. So this is my 2 meter segment. That is my support section property. And same way, I am selecting node number 2, change the cross section to support to mid. This is my 3 meter segment. Enter 3 meter and apply. And now you can see the second segment is created. Again, select node number 3. This is my mid section. I'm giving the name as, the distance is 10 meters, so I'm dividing into 2. So 5, 5. It's created. Again, node number 5. It is mid to support. That is my 3 meter segment. Added. And similar way, the last node, node number 6. It is my mid support section. This is my 2 meter segment. Apply. Now this is 20 meter span bridge. This is the elevation. Now you are seeing the tapering view. This is the taper. It's a linear type tapering. Close. Now we can verify whether we have properly assigned the cross sections to the particular element. Now just double click on the segment. This is my support section, which is highlighting in the model. This is my mid section. This is my support to mid section. This is my mid to support section. Now the geometry is over. Next is I have to provide the supports on either side. So I'm selecting node number 1 and node number 7. Go to node and element, translate. I'm translating the node to the bottom. I'm giving y direction is 3.75, comma z is minus 2 meter. It's copied one side. I'm copying one more time. It is my minus 3.75. Apply. So now we have 4 nodes at the bottom. Again, one more time I have to copy this node with the distance of 0, 0, minus 0.25 downwards. Now I have to make the connectivity from the structure to the bottom of the girder. That has to be by elastic link that comes under boundary. Elastic link. This is reflecting our bearing conditions. So it's a rigid. Copy x direction, that is my 20 meters, so that while I'm creating the link at one side, it's automatically copied on the rear side. We can see the display elastic link. Now we are seeing the elastic link which is displaying here in the model. And the next is, as how this is a line geometry, my support is not connected with the structure. This I have to connect by using rigid link because it makes a rigid body connection because it's a solid concrete members. Rigid link, this is my master node. It's a rigid body connection. Copy the rigid link, x distance is 20 meters. And the slave nodes are, I have to select in the model, that is from node number 8 and 10 are the slave nodes, and master node is 1. It will copy automatically on the rear side. Click apply. Now we are seeing the rigid link also in the model. And next condition is I have to define the support condition, that's a fixity. So it's a boundary, define support. So left side I'm fixing all the translations, selecting the bottom nodes, apply. Again on the right side I'm releasing the dx so that I will get a simply supported behavior, apply. And again I can make the display. This is my support conditions. The structure elements are connected with the bottom of the girder by rigid link, and from that point to the support, that is a bearing pad, the distance of bearing pad height is 0.25 meters. So we have simulated and connected that portion using elastic link. So finally the structure and the support is connected perfectly. Now next is we will go for loading option. So go to the load. So go to the load, static loads. Static loads, static load cases. Give the name, self weight, load case is dead load, add, and cross barrier load. This is dead load of component and attachments. And then prestress load. This is prestress load type. And then live load we will define separately. Okay, fine. Now, before applying to the load, we have to make the group. This is for construction stage analysis purpose mainly. Now go to the group, structure group, right click, click the new option. I'm giving the same name as what we have assigned to the loads, self weight, cross barrier CB, and then prestress loads, PS, add. So the three load cases we have defined. Now the boundary group is, I'm giving the group name is support and another group name is links. Support and links, two things I have added. So, oh sorry, this is a structure group. No, structure group is will be one only, that is your SG. I'm giving the name as a deck, and this I'm removing because this I have to create it in the load group. Load group is self weight, CB cross barrier, and prestress. So this is structure group, this is a boundary group, this is the load group. We have created the three load cases, that is for self weight, cross barrier, and prestress. Now all the functionality what we have done so far, that has to be connected with the group. So this total structure I have connected with this structure group, that's a deck, drag and drop, so total structure is connected with this group. And similarly, and the bottom nodes has to be connected with the supports, that's the support node is assigned with this. Support nodes, and This thing I'm connecting with the link. So apart from the link, apart from support, everything has to be connected with this group. Now how to justify whether we have properly assigned? Now go to work, right click on the support, go to table. The table is showing the group name. And similarly, for the elastic link and rigid link, right click, go to table. We are seeing the group name at the last column that is showing the link. Similarly, for rigid link, right click, go to table. So we have two rigid links which is showing the group name is links now. Now we are going to apply the loads. First one is self-weight, go to self-weight. This is a load case name, this is a load group name. So for the reference, we made the same name for group and load cases. So it is easier for us to identify. So load case name is self-weight, load group name also is a self-weight. Z is vertical, so Z is -1. Add. So self-weight is applied. Next is the cross barrier load. Go to beam load, element type, group name, load case name is cross barrier CB, load group name also is CB. This load case we have to apply at the edge of the slab on both sides. So I'm selecting the eccentricity from offset location. It is my global y direction. From the center point, from the reference point, it is to be a 6 meter, and load value is minus 2.5 kilonewton. So it is in Newton, no? So I'm changing to kilonewton. This is my minus 2.5 kilonewton per meter. Select the member, apply, and one more time, eccentricity is minus 6 on the other side. Apply and close. Now the cross barrier load is applied. Now you can see display. Now the load is applied on the edge of the slab for both sides. And the next load case is pre-stress. For the pre-stress, we have a few steps. That is, first we have to define the tendon property and tendon profile generation, and then tendon pre-stress force, that is the jacking force. And first is tendon property. Add. So give the name as tendon. Type is post-tensioning method. And material we have defined earlier. And total tendon area we have to define what is the strand diameters and number of strands. Selecting 19 number of strands of 12.7 mm dia strand. Click OK. This is the total tendon area, and duct diameter is 0.09, that is over 90 millimeter. This is by CBFIP for 5% relaxation, because this is a high tensile wire. And the factors, curvature friction factor or wobble friction aggregate slip is 6 millimeter, is considered as per the standard. Click OK and close. Now next is we have to define the tendon profile. So tendon profile, add. This is the tendon profile input table. We will create 3 cables on each web. So first we will calculate the cable coordinates in the Excel sheet, and then we will copy paste it. So I'm entering the cable coordinates for off the length, total length of the bridge is 20 meter. I'm entering the cable coordinates for 10 meters so that I can make it a symmetric tendon. This is the cable coordinates. I'm entering y is 0 and z is point is starting from minus 1 meter, and this calculation will be this minus 0.05. This is the coordinate for my second cable. This for third cable. And this is starting point from 1.3. 0.5. Okay, 0.4. This has to be 1.1. This has to be 0.8. So fine. So this is the cable coordinates randomly we have calculated. Now we are going to use this one. Before that, here what is the information I have to fill? That is the first I have to mention the tendon name. That is the T1 I'm giving. And tendon property. This is the tendon property which we have defined now. And the assigned element, select the element, it will automatically identify the element numbers, and the input type is 3D because we have calculated the cable coordinates in x, y, z directions. And this is the profile reference point. We are referring the coordinates from the element location and the cable values. This is my first cable coordinate, copy, paste, make symmetric tendon, and the profile insertion point is the starting point of your cable profile. That is your element number 1. From element number 1, I10, it is starting. So that's why element number 1 and I. Apply. And then change the name to T2. Remove the existing coordinate. Now copy paste the second cable coordinate. Make symmetric. Apply. Next is the cable 3. Remove the existing coordinate. Go to Excel sheet. Copy the cable coordinates. Paste it. Make symmetric. Apply and cancel. So we have 3 cable coordinates. Now we can see the cable in the geometry. So this is the cable which we are seeing, and we can see the profile point also. This is the cable profile points, which is located at the center web. Now I have to create a similar web on the outer similar cable for the outer web also. So instead of doing the procedure, the same procedure again, I can directly copy from the existing cables. So I'm selecting all the cables, copy, equal distance is my 0, 3.75, 0 is the coordinate of the center web, center of center web. With the correctly assigned element, click OK. It's copied. Now we are seeing in the geometry. And copy one more time, equal distance, that is my 0, minus 3.75, 0 with the currently assigned elements. Click OK. Now the 3 cables are copied on the outer web also for the sides. Now we have total number of cables are 9. And next step is Attendant Prestress. So apply Attendant Prestress. This is my load case name. This is my load group name. And these are my attendant, the name which I provided. We am selecting all the cables. I selected all the cables. If in case, if you are following the pre-stressing in stage wise, or if in case your cable, all the 9 cables are not stressing at the same day, in that case, you have to create the different load cases. That is our PS1, PS2, PS3. So we have to generate the number of load cases and load group. As you have assumed here, all the cables are stressing at the same day. That's the assumption. Based on that, we are giving this details. But practically 9 cables may or may not be possible. In such situation, you have to create the number of load groups and load cases. Now, this is the stress value or force value. We are giving the pre-stress input as a force value. It's a both-end jacking, so I'm selecting both sides. Now I'm changing the unit again to 10 force. I'm giving the force as 220 on each side. Grouting after one construction stage. So this calculation will be takes place while we entering the information in construction stage analysis. So grouting after one stage, add and close. Now you can see that prestress force which is applied 220 on both sides, though we are seeing the values on both sides. Okay, the prestressing part is over. Next is the live load. Go to the moving load, select the standard, BS standard, traffic lane, add, give the name as a lane 1, lane width is 3 meter, eccentricity following 3 meters from the reference axis, that's from the center point. And your vehicle load distribution is a line element because we have only single line geometry. So selection by 2 points. This is my first point, this is my last point. And click apply. And again change the lane to lane 2. Eccentricity is minus 3 meter. Remove the existing points. Select by 2 point one more time. Starting point and end point. Apply. Click OK. So we have defined the 2 lanes. Now that I can see, this is the 2 lanes which is created in the geometry. So fine. So next step is we have to define the vehicles. So go to vehicles, add standard vehicle. So as per the standard vehicle, here these are the types. We will follow HA and HB. Combine one, or you can select HA separately, HB separately. Let me select HA and HB separately. This is my HA vehicle. Apply, it's added. And second is HB vehicle. Apply. So 2 vehicles we have selected. OK. And close. And next step is we have to define the moving load cases. Go to moving load cases. Add. Giving the name as moving load case MVC. Now here select the load model. Standard load BD 37/01 BS 5400. And auto live load combination, it will do the automatic condition for the severe case. And for the type of design is combined factor. This is for serviceability limit state or ultimate limit state. Generally for live loads, we are checking for serviceability limit state and check the serviceability condition. And combination of loads, I can make it combination of 2 or 3 or combination 1. Let's make the more combinations so that we can get the more critical functionality. So I'm selecting combination 2 or 3. And the subload cases, we can create, add. Yeah. Yeah. Let me combination 1. Is it showing? Yeah. Okay. Now I'm making the standard load and special load. Now I just modified to the special load cases. This is standard load HA, and this is the lane 1. Add. Lane 2 also is added. This is for moving your case for HA vehicle, and change the name to MVC HA. It is not taking. Okay, let me define one more special vehicle over here. Then I can complete this one. So go to vehicle, HA and HB. Pedestrian load also. I'll check HA and HB combined also. I've selected four conditions. Let's check the critical function over there. Add MVC for the special load case. Let me see. Okay, here you can see the yeah, it is for the pedestrian load case. One lane is pedestrian. Number of lane is 1 only. Yeah, it's added. Again, this is added. Again, second for the live load case. HA loading for both the lanes occupied. This is another critical condition. The first one is for the pedestrian case, second is for the live load. This is for the load case MVC underscore HA loading. So the second condition is created as per the manual condition, because auto loaded combinations, it's compulsory you have to make one special vehicle. Now it's a special load as per the manual combination. Standard load is HA, special load is none. There's no special load. Selected both the lanes, selected and click OK. So we have two conditions. One is for pedestrian, one is for live load case, and click OK. So the loading part is completed. And then next is we have to create the construction stage analysis. This is especially for to calculate the time dependent effect under the construction. Now this is a load construction stage, define construction stage, add. This is the construction stage analysis table. So generally here we are activating and deactivating the groups according to the construction sequences what we are practically applying at the site. I'm giving the name as CS1, that is our construction stage 1. Duration is 30 days. This is the structure group. The name we have created as a deck, and age of concrete at the time of activation of the member is 10 days. Add. So at the time of construction, what is the age of concrete? The structural behavior will be calculated according to the actual age of concrete. That is the purpose of doing creep and shrinkage and compressive strength parameters. A second is boundary condition, support and links. We have created two groups for support and links, and these are the original support. I'm selecting original condition and click add. And then the loading part, the sulfate is activated at the first stage of construction stage, that is our sulfate at first stage, add. Again, the prestress which is activating at the 14th day of first construction stage. Generally, while we are activating any loads, we can see the activation is first and last. This is by default. If you want to make any load application on in between this first and last duration, we can define the duration here. This additional step, number of days is 14 days. Add. Now you can see pre-stress activate at the 14 days. So by default, it will show only the first and last. In between, if you want to make it, you have to add as additional step. That number of stage will display in the activation level. Add. So sulfate is first day, pre-stress at the 14th day. And then apply. So construction stage 1 is created. Now CS2, that's the construction stage 2. So this is the duration. So element is already activated, boundary is already activated, only the load. So now it is the cross barrier load I have to apply at the first stage of second construction stage. I'm activating cross barrier. Add and apply. And one more construction stage I am defining. This is for the long-term loss, that is my 10,000 days, to calculate the creep and shrinkage for long-term conditions. And click OK. So we have defined 3 construction stages, CS1, CS2, CS3. Total duration is 10,060. So this is the work we have done. Okay. Now let's perform the analysis. So analysis is completed. Now, result part. First, we have to do the load combinations because we have to check the result for the critical conditions. Yeah, and here, when it comes to the combination wise, here we are having ASO and Eurocode. So let's follow the 1 minute. Let me see the general combinations. Mainly we are looking for the British standard. The code wise it was not updated, so we are following the things by American standard. So this is the load combination for the service condition and fatigue condition and envelope case. So there's a 2 type of combinations. One is general combination and concrete design combinations. So the general combination will give you the serviceability condition, fatigue condition and envelope case. When it comes to the design combination, you will be seeing serviceability and fatigue. So the envelope case, it will not give in the concrete design, it will show only in the general combinations. Fine. Now we'll see the result. First one is the reaction forces. We can see the individual load cases as well as the load combinations. We can select any load combinations for getting the results. This is my values and legend. This is the reaction force for the particular combinations. And the red one, it's showing the maximum reaction we are getting out of all the support conditions. Next is a deformation. Deformation contour I'm selecting for the same load combinations with a deformed shape. This is my deformation contour. And then forces, beam diagram. My is the bending moment. This is the bending moment shape for the particular combination. And Fz is the shear force. Fz is the shear force, and Mx is the torsion. And the next is the stresses, beam stresses. And as per this reference picture, the diagram which is showing one component 1 and 2 are the top stress, 3 and 4 are the bottom stress. We can see the stress concentration and how the structure is behaving. Fine. So this is the analysis of a box girder bridge as per the British standard. Now I will show how to extract the result. There are several ways of taking the result. That is, we can take the input file first of all from File, Export, MCT file, and save the file. It will show the complete input file data. So this is the one. This is the input file. And you can take the output file, standard output file. This is a text output, comes under result, new load set, click OK, next, select the beam element, select the displacement and reactions, next, and finish. This is the total text output file. This is for showing all the load combinations. Okay, this is the input file and output file. And next is how to make a customized report generation. That is comes under tools, dynamic report generator, new document. So this will show the MS Word in my screen. This is a normal Word file. So before that, we should define what are the results we should extract in our customized report. Suppose I want to take this deformation shape, right click, dynamic report image, save the file, support condition. Suppose you want to have this table, right click, dynamic report table, add it. And then reactions, this is a reaction picture, right click, dynamic report, save it. Deformation, this is your displacement contour. If you want to make this displacement contour in your report, you can just select and right click dynamic report image, save the file, and then forces, beam diagram. This is my bending moment shape. Right click, give the name and save, and then FZ is the shear force. Right click, dynamic report image, save the file. MX is the torsion. Right click, dynamic report image, give the name, save. And stresses, it's the beam stresses. Right click, dynamic report image, save the file. So these are the results we have saved. It is saved in the tree menu. The last tab is report. The entire picture and tables are saved here. While creating the dynamic report generator, we can just drag and drop. It will create your customized report as per the way you want to. And then for the result for the pre-stressing, I am showing the result table. There's a tendon coordinates. This is showing the tendon coordinates. This coordinates you can directly paste in the report also. Right click, dynamic report table, and save the file. Similar way, tendon losses. So this is the cable number 1, and this is the cable loss. This is your you can see the two tabs here. This is stress and force. As we give as the input as a force, so we can check the result in terms of force only. We have applied the 220 ton force as the input. Now this is the column which is showing the force remaining in the member on the cable after friction slip. Now the remaining force is edge is 181, nearly about 199. And this is elastic deformation loss, this is a creep and shrinkage loss, and relaxation loss. So this is for the cable 1, T1, and construction stage 1, CS1. So this table also you can extract, you can paste it in the table, right click, dynamic report table, save. Now this is the report generator which is showing the MS Word file in MIDA screen. These are the results which you have saved here. You can select these results. You can just drag and drop in the Word file. So this is generated your report. Now you can see your pictures are placed over here. Next is do one by one. This is the tables. Tendon loss. And this is the cross-section details. You can see the cross-sections, support section. This is the mid-section property. Support to mid-section. This is a mid to support section. Fine. You can give the header and footer also. This header, you can make it project name, email address, telephone, like that. And the footer, you can make your file name, modified date, like that, so that it will make your footer and header accordingly. Now you can see it is displaying over here. Now you can save this file. save the file and click close the file here. Now I will open the report file which we generated. Yeah, this is a base code model report. This is the report file which we have generated now. Now you can see the footer and header also is coming. And this is the way we drag and drop. So this is the bending of, this is our deformation shape, reaction forces, stresses, shear force, bending moment, torsion, stresses, and the table values. And then the below, this is the cross section. The property of the cross section, the program will give directly. This you can take it directly, and what are the modifications if you would like to do, you can do accordingly. This file is like a normal Word file only. You can do any modification further. So this is the report generation, and the highlight of the report generation, once the report is generated, after that if you are still working on the model, if you are doing any modification in the model, this saved file, this Word file, you can import again in the software. That is, go to Tools, Dynamic Report Generator. Here you have an open document. After generating the document, further you are doing any modification in the model, again open the same document. The modification will be implemented in the existing document by automatically. So this is the main highlight of the report generator. This is very, very helpful while we're doing repetitive corrections in the model. Fine. So do you have any questions to me? Hello. You can type your questions in the questions box. This is my contact details. I'm sharing for you. Okay, if you have any further doubts, you can contact me either by mail or by Skype. Okay, thank you very much for joining this webinar. I will send this webinar video link for the reference. You can practice the model and send the model which you can prepare it to me. We will check the model and do further shortcuts to make your model very quickly. Bye.